Welcome back to part 3 of this recording series. In part 2, we were starting up the server. We had the USB thumb drive inserted into the server and booted into the ProLiant Service Pack SPP. And we also installed some new RAM, and that was found during the boot up during post. This is a screenshot here showing the 3 modules that detected as not installed. I just powered down the server and reseated those modules, and I'm going to power it back up and see if it's the same status. If it's the same status, I'm going to RMA the memory modules. So let's see what happens when we turn it on. And again, this will take a few minutes to boot up before I see something on the screen. Right now it shows no video, and I'll wait for communication and authentication to take place. So we're still waiting on the server to boot up. Should just in status here any minute now. And here in that integrated management log, you can see the post errors during the last time we booted up. That's post error 207, memory initialization error on processor 2, DIMM 1, 2, and 3. And those are the ones I just reseated. So we have some post codes down here. It's coming up now. Alright, before we showed 122 gigs, and now we're showing 144 gigs. So luckily all it took was a reseat of the 3 DIMM slots there. And it's found all 18 slots, and it'll give me a total of 144 gigs on this second server. So that gives much more flexibility for our virtual lab as well. This server hosts all the production VMs, quote unquote, which will be used against TAC testing and some other production stuff to simulate a real working environment. And on the other server, we'll have all the ArcSight tools, Kali Linux, for example, ArcMC, Logger, ESM, etc. So this was the last upgrade I needed to complete both servers. I'm not going to populate slots 3 and 4 because if you populate all hard drive slots and you max everything out, add 2 RAID cards, the temperature increases and the fan speed goes up. So unfortunately this is done in a data center environment, so fan noise does increase. So just running 1 RAID controller and 8 drives is a minimal, around 33% fan speed, so not too bad. So we'll go back to our interactive firmware update. It's loading up now. And this is a photo before, or a screenshot of our last video after I stopped the video. As you can see, we started the test on the hard drives 5, 6, 7, and 8 that I installed. Any other memory modules that I added, the other 7 that were detected, I performed a test on those and got almost done all the way through. But it's not difficult. You just start the test and you can do quick or complete test. It takes a couple hours, depends on how many loops you go through. So I'm just going to go ahead and leave that running overnight as well. But I wanted to get into the firmware update with you, so we're going to start the firmware update. And this will be all somewhat manual steps, so let's take a look, see how that's done. And now we're going to click on Firmware Update. And this is the latest SPP, or Service Pack ProLiant. That's what it stands for. 2016-10-0. And you can see this is the latest HPE Smart Update Manager, or HPE SUM 760. That's the graphical interface with the Linux kernel underneath. And the SPP is where all the firmware comes from. So, but on the USB key utility maker, I used the SPP, which comes with HPE SUM built into it already. You can also install HPE SUM on Windows OSs as well as Linux. It's the same process. Listens on localhost 127.0.0.1. Starts the graphical interface. Right now it's doing an inventory of all of my components that are installed. For example, the BIOS versions, hard drives, RAID controller, anything like that with firmware will be detected. Also checks the ILO version. And once this is scanned and completed inventory, then it'll give you a list to choose from. It'll show you the current and newer firmware versions you can apply or not apply. And once everything is selected that you want, you can hit continue and it'll update the firmware to the latest version. And we'll be all done with that. Pretty simple. And again, the automatic firmware update is you start it and you walk away. As you can see, it says on localhost here, inventory completed, and there's updates required. So we'll click next there. And as I was saying, deployment summary, applicable components. So we have one update for the online ROM. It's a flash update. And it looks like it's for the drives, hard disk drives, yeah. You can see there. This is the only one that's needed. You can see the force buttons here. If you wanted to run the firmware again, you could force it to install again. Right now, it's installed as 2015-08-16, and active version is 2015-8-16, the same version, which means it's installed. And the only available version is the same version. So I have it ran the SPP since March of last year, so there's only one update there for the hard drives. If you have any warnings or alerts, it'll be down here. I'll tell you beforehand. And one last thing, you can come here under the actions. You can do reports, and you can go into advanced options. And in advanced, you can say reboot after installation. You can give it a delay and give it a message. You have some more install options here. Really your preference, what you want to do, but we'll just go ahead and continue with the update. And we'll go back to the SPP menu for our RAID configuration. So we'll close this. Scroll down and we'll hit deploy. And that's completed there. And it gives you the component, package name, the status, success, reboot required to activate new version. We're going to, since this is a hard drive update, we're going to go ahead and reboot it before we configure our RAID controllers, just in case it requires any attention there before we configure our RAID 5 on these drives. So we'll go ahead and reboot. Confirm the reboot. So that completes the firmware upgrade. It's very simple. Download the USB KeyMaker utility 2.0. Grab the SPP update after logging into the HPE support portal. Launch and install the USB KeyMaker utility. Browse to your SPP ISO file. It creates it. Insert the USB key. Reboot the server. Make sure it's going to boot from the thumb drive, USB thumb drive. And it boots right into there. You can choose automatic or interactive mode and begin your updates. So now we're going to go back into the SPP and perform the RAID configuration. And this is for our 4 new hard drives we added to it. Let's go back into interactive mode. And now we're going to select the HPE Smart Storage Administrator. This is for configuring, managing, and performing diagnostics for the smart array and storage works. Alright, so here we have the Smart Storage Administrator, version 2.6.18. Have a little drop down menu up here. You go home to the server or back to the smart array. Over here on the left here, we have available devices, server, a PA12 RAID controller. This was the card I pointed out in the first video, overview video. That was in the back. And you have the solid state devices, and you won't see these because there is no SSDs, but the PA12 RAID controller does support SSDs if you wanted to add them on. Click on server. We have some actions here for our diagnose. This is for array diagnostic and smart SSD wear gauge. Gives you reports on those, logs on the available controllers discovered on the server. So, if we go down to the smart array here, it brings you to another menu here where you can configure your RAID, and you can also run diagnostics. Any service or status messages here will be displayed, errors, warnings, failure, stuff like that. You can also click View All Status Messages for more detailed reports. Over here on the controller configuration summary, we have one data array already created and one logical drive. That's on the first four. Those were already created in RAID 5 before this video. And the 4 unassigned drives which I added. You can click View More Details. I'll tell you even more details about the controller and the current logical drives, etc. This is also on the diagnostics tool that we saw in the last video. So we have one array configured, one logical drive, one data logical drive. 8 physical drives, 4 in use, 4 unassigned. And our port assignments here, internal. These two are the 2 cables inside the chassis going from the hard disk drive caddy up to the rear of the PA12 RAID controller, which plugs into the RAID controller on board. And you can actually extend other SAS appliances like the D2700 and expand your SAS array as well add more storage if you need it. Gives the controller status, cache status, and the battery. So there's a 1 gig flashback write module installed on the RAID controller. There's also a battery. If the battery becomes unchargeable, meaning it won't hold a charge anymore, you'll get an error in the error log of the ILO, and you also will see your performance decrease on your array and your LUNs if you're using VMware. That's a good indicator. You need to check the battery on the flashback write controller, and you also see that in the post errors as well. So these batteries should be replaced every 3 years as well. And it lists the storage controller internal drive cage, which is the cage that's in the front of the server, where the server hard drives are plugged into. So let's go ahead and configure an additional array, RAID 5 array here. So we're going to click on configure here. And some of the actions you have here is create array. You can do a quick array with RAID 0. Then you can modify controller settings. Go into advanced controller settings and clear configuration. So if you wanted to delete the array, you can click clear configuration and it will erase the array configuration. You can set bootable logical drives. In my case, I have a onboard micro SD card for VMware. It boots from there, and then it reads the LUNs from VMware. So I wouldn't use that, but if you had an operating system installed directly onto the hardware itself, you can go in there and configure your boot drive. You can also change your LED lights for each hard drive as well. So let's click create array. And these are the only available drives because I've already used the first 4 and I've only inserted 4 into the new 4 drives. So we'll select all those. So that's 2.4 terabytes if you did not have a RAID set up or RAID 0. In my case, I've decided to go with RAID 5. And of course, the standards in production these days are RAID 10, which is RAID 0 and 1 combined. And a thing to note about these drives is if you move the hard drives from one server to another, let's say you RMA the server, these drives need to be in order when you remove them, meaning slot 1, slot 2, 3, and 4 all need to come out the same out of the server the same way and go back in the same way, because the array configuration is written to these hard drives, not the controller. So if you have a failed controller, you can move these drives over. The new controller on a different server will detect the array configuration and continue to boot up. We'll go ahead and click array, create array. Select your array level. So I'm going to use 5 here. And you can see little help menus. What's this? Strip size, full strip size, has to do with the type of array you configured. I always choose 512. And I keep it at 32 sectors. And the maximum size. Unless you want to customize the size of the array, let's choose maximum. For RAID 5, you're going to get 1.6 terabytes usage. Keep the caching enabled, that's for performance. So you always want to enable that. And then we'll create logical drive. And it says logical drive was created successfully. And it gives you the status, the used space. Unusable space is 2.1 terabytes. Total usable space is 2.1. And after RAID 5, you get 1.8. These are 600 gig drives, all four. I'll click finish. Now you can see over here on the right we have 2 data arrays now. 2 logical drives, 8 physical drives. You can see more information there. Now we have some informational messages here. Tells you it created an array. And as soon as you start up hard drives, it undergoes a parity initialization, so it needs time to work on that. If you try to load up your server, like for VMware, start powering on VMs while it's trying to perform the parity, then you have slower performance. And this may take up to a week to perform. So depending on the hard drives and the hard drive size, the array size. So I'm going to let that run for a few hours, probably 12 hours, and then come check on it later on. And we can go back if you wanted to modify controller settings, transformation priority, rebuild priority, surface scan, and physical write cache state. And you can see the logical drives that are created here, array A and B. And in VMware, when you go to storage to manage the storage, this will be considered LUN 0 here, presented to VMware, and this will be LUN 1. So 1.6 terabytes, 1.6. Here's our 8 drives, and 0 unassigned. You have a cache manager and license manager. So that completes this video for now. The next video I will create will be adding the storage, the LUN 1 to VMware for this server. And again, thanks for watching, and check out more videos at Vanquish Security/blog. And I also have a YouTube channel. Search for YouTube on YouTube, Vanquish Network Security. Thanks.